So we're in our exponential unit, and it's the perfect time to review exponent rules. You have probably seen these before in Algebra 1, 2, so for many of you this might be a review. For others, it'll feel like a long time ago, and you'll want to really make sure you're paying attention and getting a good grasp of the way exponent properties function. To start this, we're just going to review some of that vocab that we need to talk about exponents. So if you're looking at your purple sheet, we'll see that for starters, we just want to define the different pieces of an exponent. So the 3 up here, that is the exponent. And we also sometimes hear it referred to as the power. You might also hear it referred to as the index at some point in your life. We're not going to be using that term very much in this class, but I just wanted to introduce that. Down here, the 2, the really big 2, is the base of the exponent. It's easy to remember because it's at the bottom, right? It really does look like the base of something. And if we have 2 to the 3rd power, it really just means 2 times 2 times 2. So 2 times itself 3 times. To complete this sentence, the exponent tells you the number of times to multiply the base by itself. So you're multiplying the base by the base, and this is the number of times you do that. In this case, 4 to the 5th power would then be 4 5 times. So we can fill that in. Multiply 4 5 times. All right, as we move through this sheet, we're next going to be talking about the exponent. Again, it's just written the exponent, sometimes called the power. And again, that just helps us talk about exponents. So the more comfort we have with math vocabulary, the easier it is to identify our questions, to ask our questions, and to have conversations about these topics. So I just wanted to go over this. 5 to the 3rd power, that's what it sounds like. 5 to the power of 3, right? Or 5 to the 3rd power, either way. 6 raised to the 2, 6 to the power of 2. This could also be written as 6 squared, right? So we have a different language when we have the 2 here. Same with this. This could also be written as 5 cubed. So we have some special words for the 3rd power and the 2nd power. When it comes to this, see if you can write that on your own. We have a base of 2. We have an exponent of 3. How could you write this in a sentence? So you could say 2 to the power of x. This should be capitalized. That would be one way to do it, right? All right, as you open this book, if you haven't folded it over, you can fold it over now. As you open it, you'll see lots of different exponent rules. And you're going to be taking this to the next step and actually thinking about specific exponent properties that will help you solve equations. Okay, we're going to be looking at a few different properties, and as we go through this, take notes on your page so that you have access to these properties. The first is something that looks like this. If we have x to the, I know this is a little hard to read, so I'm going to draw over it, x to the 2nd times x to the 3rd. Well, x to the 2nd is x times itself 2 times. X to the 3rd is x times itself 3 times. And when we expand it out like that, we can see, okay, so that must mean this is x to the 5th. So x to the 2nd times x to the 3rd can be rewritten as x to the 5th. We look at this example down here. We have a coefficient, which makes things a little bit more interesting. We have, so this is 6x to the 3rd times 2x to the 5th. So I have 6x times x times x times 2 times x 5 times. And that gives me 12, and then I count my x's, 1, 2, 3, 4, 5, 6, 7, 8, x to the 8th. So that's my final answer. In general, multiplying exponents is like addition. Because really, if you can see, we're actually adding those two numbers to get there, right? So we're multiplying these two things and then adding 3 plus 8. So our general rule is going to be x m plus n. If you have something like this, you add those two exponents, and that will give you a quick way to do the multiplication. Our next rule is division. So if you see a division problem involving exponents, you're going to want to be thinking about this rule. And we have x to the, I believe that's 5th, over x to the 2nd, x times x times x over x times x. And if we know our division properties well, we should know that these two things divide to 1. These two things divide to 1. And so we are left with x to the 3rd. If we start to think about, okay, how do those numbers relate to our exponents, we can see that, oh, well, x to the 5th minus 2 would give us x to the 3rd. And indeed, that is a property we're going to be able to formalize here in just a moment. If we look at another example with coefficients, we have 10 times x 7 times. X 3 times. Again, we do our canceling out. So 1, 2, those 3 cancel out. We're left with, whoops, gotta put my 5 here. 4x on top, and then I divide these two things, 2x to the 4th. 7 minus 3 is x to the 4th, and so our theory holds true. Division is then like subtraction. And x to the a over x to the b can be thought of as x to the a minus b. Is our shortcut. Okay, moving along, we have a power to a power. So x squared to the 3rd power is x squared 3 times, which is then x to the 6th. 1, 2, 3, 4, 5, 6. We know that 2 times 3 is 6, so we might think, okay, maybe there's something to that. When it's a power to a power, maybe we're multiplying the decimals. If we look at another example, 4x 5th to the cubed, we're going to get 4 times x times x times x times x times x. And we're going to do this 3 times. So 4 times 4 times 4, that would give me 64. And then I just count the number of x's I have, and that's 15, or x to the 15. Indeed, 5 times 3 is 15, so I think we can conclude that power to a power is like multiplication, which translates to x to the n to the m means x to the n times m. So that's going to be our shortcut. Over here, we have to start thinking about negative powers. I'm going to do these examples first. So if we have x times 2, or excuse me, x times x over x times x times x. 1, 2, 3, 4, 5, 6, 7, 8. Well, first I have to cancel. Divide to 1, divides to 1, divides to 1. And I'm left with nothing in the denominator, so I write a 1 there. I'll hold that place, and I have 1, 2, 3, 4, 5, 6, and I have x to the 6th. So that's one way to write this. Another way to write this, which we're going to talk about, is with negative exponents. So we need a way to write 1 over x to the 6th, and we use negative exponents. Again, we remember with our division, 2 minus 8 gives us negative 6. So that is one of the other reasons we write the negative exponents such that they correspond to 1 over x to the positive 6. All right, over here, one more example. So we have 4x times x over 20 times x times x times x times x times x times x. And again, we are going to cancel first of all. Take our green, 1, 2, 3. I know that 4 over 20 can be simplified to 1/5. And then I have 3 x's left on the bottom here. So x to the 3rd. I also know that 3 minus 6 is negative 3. So I could write this as 1 over 5 x to the negative 3rd. In general, negative powers have to be rewritten as positive powers dividing 1. And we'll talk about later on how we can think about that in terms of reciprocals. But in general, right now, you just need to know that they can be rewritten in this way. Let's talk about a formal rule. X to the negative a, well, that can be rewritten as 1 over x to the power of a. 1 over x to the negative b, well, that actually becomes x to the power of b, right? It's positive. All right, x to the 9 over x to the 9, well, if we write that out, 4, 5, 6, 7, 8, 9. Take me a second here. 1, 2, 3, 4, 5, 6. All of these cancel out, right? 1, 1, 1, 1, 1, 1, 1, 1, 1. They divide to 1, so we're left with 1. Anything to a 0 power is 1. X to the 0 is 1, right? 9 minus 9 is 0, so that's how we would get x to the 0 from that, and we get 1. If we write this out with another example with coefficients, we have 8 over 1, 2, 3, 4, 5, 2, 1, 2, 3, 4, 5. Same thing over here where all of these cancel, and we're just left with 8 over 2 times 1. Well, 8 divided by 2 is 4, so we're just left with 4. And fractional exponents are the last thing we're going to be talking about. Fractional exponents, you've seen fractional exponents a lot, actually. Every time you work with a square root or a cube root, you're actually working with fractional exponents. So x to the 1/3, well, that is taking the cubed root of x. So one way we can write that is 3 cube root of x, right? We're asking ourselves what times itself 3 times gives us x. All right. 16x to the power of 1/2 is really the square root of 16x. So the second root of 16 times x, right? If we were to solve that, well, we know that the square root of 16 is 4, and we don't know what the square root of x is, so I would just leave this as 4 square root x if we wanted to simplify that. Fractional exponents can be written as radicals, where this is the radical sign, and the number on the outside of the radical is telling you what root you're taking. So this is the cube root, this is the square root. We can do fourth roots, we can do fifth roots, we can do whatever roots that we want, right? So fractional exponents can be rewritten as